All right, here we go. Day 2 of Gauss-Jorden, Gaussian. We did Gaussian elimination yesterday. What did you have to be careful about when you went to get this 0? What row did you have to use to get that 0? Row 2. All right, so when we got this lower triangle, we had to use row 2 to get this 0. In Gaussian, we got the zeros, and then we divided by whatever coefficient this was. Sometimes it created ugly fractions, so we just went to the previous step. But we had to do substitution all the way back up, which was annoying. So this Jordan came along and said, well, Gauss's method, that's why we call it the Gaussian method, is awesome, but let's extend that algorithm a little further so we don't have to do any substitution. So Gauss-Jorden does the same thing Gauss did in finding a 0 here, here, and here. But then Jordan took it a step further and said, let's continue the algorithm to get a 0 here, and then lastly here. And guess what? By doing all that, all you have is your coefficient and your constant. Coefficient and constant, coefficient and constant. You divide by each row by its coefficient, and you immediately have your answers for x, y, and z without having to do substitution. Yes, it does require finding those other 3 zeros first, which is 3 more steps. But you're going to have to be proficient on these methods also. Notice, too, it says here when we go to find this position, just like the bottom one, we need to use row 2. Also, when we're finding these zeros or making those zeros, it's telling us to use row 3 to do this. One thing that we didn't talk about yesterday, we did talk about multiplying one of the equations by a non-zero real number, like when we divided by a number to reduce the numbers in the equation, or multiplied. We did like elimination type methods where we added multiples of one equation to another to replace a line. What we didn't do yesterday is interchange 2 equations. Now you can do this at any point in the process, but if it screws up all your zeros and puts them in the wrong place, then you're back to redoing those, and that's a pain. So generally, we say that you should try to do this at the beginning or towards the beginning of the solving process. You could change them later, but only if it's convenient and puts your zeros where you want them to be. So notice those same steps are written in your notes here, are those same things that we can do to the matrices. Gauss-Jorden elimination. The whole goal is to get this 0. That's why I'm going to put 0 sub 1. It's the first 0 we get. 0 sub 2, 0 sub 3. We're going to have coefficients for x, y, and z that we'll have to undo at the end. But instead of getting this triangle and the dividing by those coefficients, we're going to leave the coefficients as they are so that we don't have to deal with ugly fractions. And Jordan adds that we need to get a 0 here for our 4th one, a 0 here for our 5th one, and a 0 here for our 6th one. Now, if you remember yesterday, I said that you could get these zeros not necessarily at the same time. You got to use different things, but you could go from the first matrix to the second by getting those both in one step if you wanted to. Similarly, we can get these two at the same time in one step so that it saves us having to rewrite the matrix as many times. We're going to start with a 2 by 2 matrix. Again, probably the most efficient way to solve this system is by elimination or substitution, but we've been asked to do Gauss-Jorden. It's also going to set us up to see how it works with a 2 by 2 to transition to the 3 by 3. So we start with our original matrix of 3, negative 9, negative 6, and 1, 1, 2. And the first 0 we need to get is right here. So I'm going to multiply, to get this new row, I'm going to do, my new row 2 will be row 1 plus negative 3 times row 2. And I'll show that work right here. I've got 3, negative 9, negative 6, and negative 3, negative 3, negative 6. When I add those up together to get my new row 2, that gives me 0, negative 12, negative 12. Row 1 stays as it was, 3, negative 9, negative 6. If we were doing this yesterday, we'd say, oh, just divide by the coefficients and now plug this back into the other equation to do substitution. But we're not. We're adding the Jordan piece to it, which means we need a triangle of zeros in the lower left corner. Done. And we need a triangle of zeros in the upper right corner. So we need to make this a 0. Before I do that, I'm going to, because 12 goes into both of these, negative 12 does, I'm going to multiply row 2 by negative 1/12. Or rather divide by negative 12. It just makes it a little easier to work with. So 3, negative 9, negative 6. You can do that at any point if you see, like even this, you might say, hey, I could multiply that by 1/3. It would simplify it, make it easier. I don't feel like doing that though, so I'm not right now. So 0, negative 1, negative, nope, 0, 1, 1 is what I have. So again, I'm trying to get a 0 here. To get that 0, and I'm going to bring that matrix over here, I'm going to take row 1 as it is. I'm going to multiply row 2 by 9 and add them up. So if I multiply row 2 by 9, that's going to make this 9 and this 9 and this 0. Which is going to give me a new row 1 of 3, 0, 3. My row 2 stays exactly as it was, 0, 1, 1. Now we've completed Gauss-Jorden. The only thing we have to do is divide by the coefficient that's not 1. So if I divide this entire equation by 3, I get 1, 0, or that entire row by 3, 1, 0, 1, and 0, 1, 1. This top one tells me that x, when y is 0, x is 1. When x is 0, y is 1 for the bottom row. So there's my final answers. So again, the process is, like yesterday, get triangular form. But this time we're not dividing these unless they go in evenly. Then get a 0 up here, and then divide by the coefficients so we can get our answers directly. We're going to take a look at this in just 1 second, the next example.
We have some good-looking students this hour.
Okay, so we saw a 2 by 2. Now we get to look at a 3 by 3. Woohoo! All right, yeah, so exciting. These matrices are fun, but they don't start with an F like fractions, functions, and all that stuff. So, all right. So our initial matrix is 1, negative 1, 1, 0, negative 1, 2, negative 3, negative 5. And 2, negative 3, 5, 8. Please try to make sure you follow my calculations because in the other class this morning, I screwed up all kinds of signs. Like I wrote the wrong sign down. I multiplied wrong. Not on these problems, but on other stuff. So, all right. So we're trying to get this to be a 0. That's our first one. And then we're going to target this one next. If I can do it in the same matrix, I will. Let's take a look at that. To get this one, it's going to be a nice calculation. Guess what I'm going to do? Add row 1 and row 2 together. Row 1 plus row 2, which is going to, I'm keeping row 1 as it was, so I'm just going to copy that down. Row 1 plus row 2 is going to give me 0, 1, negative 2, negative, I think that's right, yeah, negative 5. Questions so far? Now, I don't want to rewrite this whole stinking matrix again, so even though I know that technically you're only changing one row at a time, I'm going to get this one. And I'm actually going to do it with, doesn't matter which row. Which row do you guys want to use, the old row 2 or the old row 1? The old row 1? Okay. So I'll do negative 2 times the old row 1 plus row 3. So that'll give us negative 2, positive 2, negative 2, 0. This becomes 0, this becomes negative 1, this becomes 3, and that stays 8. Any questions so far? Maggie, you okay? Yes, sir. Why did I put the 2 here? I was showing how I went from this to this. This will be my new row 3. This one was my new row 2. I'm doing 2 to go from one matrix to the next, doing 2 at the same time. which instead of just recopying this and then doing it all over again. Oh, you're on the other problem. Okay. So now our next goal is to get a 0 here. Which row do I have to use? Second row. Yep. So this one's nice. I just got to do row 2 plus row 3. So here's my new matrix. 1, negative 1, 1, 0. 0, 1, negative 2, negative 5. I've kept those the same, but this one becomes 0, 0, 1, 3, not 8. Because you got to add row 2 and row 3, negative 5 plus 8. Be careful. Normally, we'd be like, hey, this is what we did yesterday. This is Gauss right here. Look, they've even got the 1s. So you'd be like, oh, let's do substitution. No, thank you. I hate substitution. So our next goal is to get a 0 here and then a 0 here. Let's do this one first. What am I going to multiply row 3 by?
2.
So my new row 2 is row 2 plus 2 by row 3. I'm going to do that under here. It would be 0, 0, 2, 6. So my new row 2 looks like this. 0, 1, 0. Yay, that's what I wanted. 1. Now, which row am I going to keep the same? It's the row I never want to change, right? 3, because 3 is exactly as I wanted. I don't want to change 3 ever again. I'm going to just keep writing that same thing down. Now, I could technically do this in a separate step, but I don't want to rewrite my matrix, so my next one is going to be this one. To get my new row 1, I'm going to do row 1 plus the opposite of row 3. The opposite of row 3 would be 0, 0, negative 1, negative 3. So when I add those up, I've got 1, negative 1, 0, negative 3. Any questions so far? I could do that in the separate. Some of you like to do it as only change one row at a time and write it out separately. You can. There's enough room to do it. We're almost there. Do we have the upper right triangle? Not quite yet. Which one do I need to change? Which number? Row 1, column 2. This is the first row, the second column. Row 1, column 2. So that is the one I need to get to be a 0. Guess which row I have to use? Use row 2. And what's nice for this particular problem, it doesn't always work out this way, is these are opposites, so I can just add row 1 and row 2, which will give me 1, 0, 0, negative 2. And then the other ones just stay as they were. 0, 1, 0, 1, and 0, 0, 1, 3. So that means my answers are x equals negative 2, y equals 1, and z equals 3. I should plug these back in. I'm going to check real quick. That's negative 2 minus 1 is negative 3, plus 3 is 0. So that works. That's 2 plus 2 is 4, minus 9 is negative 5. That works. Negative 4 minus 3 is negative 7, plus 15 is 8. So it does work in all equations. So I know we did this right. We didn't make any arithmetic mistakes or any precision errors. So same as Gauss, and then we go after this 0, and this 0. Letter C, we're going to see something unique in this problem. So let's start by copying our matrix, the 4, the 9, the 16, and the 2. The negative 1, negative 2, negative 4, 1. Oh, negative 1, careful. 2, 4, 9, and negative 5. All right, so I am going to use row 3 and row 2 to replace row 2 in my first step. And that's where it's going to get interesting. And you're like, why is that going to get interesting? You'll see. Row 2 is going to be the current row 3 plus 2 times row 2. Since the signs are already opposite, I just have to multiply this one by 2. I'm going to do that work right underneath. That's -2, -4, -8, -2. That's this times 2. My row 1 stays exactly as it was, because I haven't changed that yet. I haven't even changed row 3 yet, but I'm changing row 2. Changing row 2 is going to give me 0, 0, 1, -7. If I added that correctly, I did. Here's, you say, oh, but it actually is kind of nice in a way. It's not nice in one way and kind of nice in another, because if you remember, there's something we are allowed to do. We are allowed to interchange any two equations, so interchange any two rows. What row would I ideally have looking like this? Row 3. This is what I really would like to see in row 3. So we're just going to switch row 3 and row 2. Okay? Our old row 3 and our old row 2. Now what that means is that this was my row 3, so I'm going to treat this now as row 2. It's a little confusing, so bear with me. We're going to write down the 4, 9, 16, 2. This will become the row 3, 0, 0, 1, -7. I need to get a row 2, and it has to come from, I'm just going to write this down, that this was the 2, 4, 9, -5, and that's going to be our new row 2. But I need it to be a 0 here, right? So what am I going to do with the equation with the top, with row 1 and row 2? I'm going to do row 1 plus -2 times, well, right now it's row 3. It's going to be row 2. So that's 4, 9, 16, 2, and -4, -8, -18, +10. This gives us 0, 1, that's good, -2, 12. Any questions so far? All right. Now, it's nice that those are 1s right now, but they're not always going to be 1s. And so I will probably leave them whatever number they are unless it divides evenly into the other ones. So at this point, we're targeting this and then the 16. And to target those, we have to use row, which row? Row 3, because we want to just change just those numbers. We don't want to change this number. So I'm going to do, to get my next matrix, leaving a little room there, I'm going to do row 2 plus 2 times row 3. And here's what that's going to look like. 0, 1, -2, 12, and 0, 0, 2, -14. I'm keeping my row 3 as it is because it's perfect. I don't even have to divide by a coefficient. It's already got an answer for z. This adds to 0, 1, 0, -2. So now I even have an answer for y, which is nice. Up top, I've got, to get that to be a 0, I'd have to multiply this row 3 by -16. So it'd become 0, 0, -16, yikes. Negative is positive, 16 times 7 is 112. So that right there, to replace row 1, is going to be row 1 plus -16 times row 3. So that's where you're seeing these blue numbers come from. So that's going to give me 4, 9, 0. And then 2 and 112 is 114. Any questions? All right, so now we've almost completed the triangle of zeros in the upper right-hand corner. The next one we have to target is the 9. And I'm going to use row 2. So row 1 plus -9 times row 2 will give us our new row 1. So that's going to be 4, 9, 0, 1, 14, and 0, negative 9, 0, positive 18. This gives us a new row 1 of 4, 0, 0, 132. 0, 1, 0, negative 2, 0, 0, 1, negative 7. There's only one thing left to do. Divide row 1 by 4, or multiply it by 1/4, giving us a final matrix of 1, 0, 0. I think it's 30-something. 33. 0, 1, 0, negative 2, and 0, 0, 1, negative 7. So our answer for x is 33, for y is negative 2, and for z is negative 7. And we can plug those back into the original equations just to make sure that they do make all three of them true. But that's the solution to that 3-variable system. The assignment that goes with this section, remember, if you get stuck, go back to either these examples or this handout. It even tells you which row to use to get those zeros. The assignment is a worksheet for day 2. This ends the video.